Now we're going to take up one more problem on shaft. The problem number 18. It reads as a hollow shaft of 200 mm outer diameter has the same area as that of a solid shaft of diameter 100 mm. Number 1. Compare the power transmitted by the hollow shaft with that of the solid shaft for the same speed. Then number 2. Compare the angle of twist assuming the same length and the material of the shaft is same. So we have D naught is 200 mm and D, which is the diameter of the solid shaft, is 100 mm. So as it says, having the power hollow shaft that of the solid shaft, AS will be equal to AH and NH is equal to NS because the power transmitted. Small LH is equal to small ls because same length, and the material of the shaft, which is tau h, will be equal to tau h. As both the shaft have the same cross-sectional area, has the same area, he says. So AS will be equal to AH. So that is pi d square by 4 will be equal to pi by 4 into d naught square minus di square. So you know pi by 4 get cancelled. So d square is 100 square will be equal to d naught square, which is 200 square minus di square. So inner diameter of the hollow shaft di will be equal to 173.2 mm. So now we go for the comparison of power transmitted by the shaft. So N capital N will be equal to 2 pi nt by 60,000 kilowatt. So as both the shafts have the same speed, power is proportional to the torque transmitted by the shaft. So the power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will be equal to torque transmitted by the hollow shaft divided by torque transmitted by the solid shaft. So capital NH by capital NS will be equal to capital TH by capital TS. So TH will be equal to pi by 16 into tau h into d naught to the power of 4 minus di to the power of 4 divided by d naught the whole over divided by pi d square by pi d cube by 16 into tau s. So on pi by 16 gets cancels and d naught tau h will be equal to tau s. Those things also get cancels. That is equal to d naught to the power of 4 into 1 minus di by d naught whole to the power of 4 and close the bracket divided by d naught into d cube. So as the tau s will be equal to tau h. So d naught cube, d naught gets cancels in the denominator and also in the numerator. So d naught cube into 1 minus di by d naught whole to the power of 4 divided by d cube. So substitute the values. So that will be equal to 200 cube into 1 minus di is 173.2 by divided by 200 whole to the power of 4 and close the bracket divided by d cube, which is 100 cube. So on simplification, you will going to get it as 3.5. Therefore, power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will be always have the ratio of which will be equal to 3.5. So the comparison of angle of twist, the next one. So as LH will be equal to LS, which is given in the problem, which is same length, and GH is equal to GS, which will be equal to same material. So from the torsional equation, G into theta by L will be equal to T by JP. So therefore, theta will be equal to T into L by G into JP. So theta H by theta S will be equal to TH into LH by GH into JPH divided by TS into LS divided by GS into JPS. As that the ratio what he has given, which will going to be theta H. So therefore, 3.5 will be into a JPS by GPH. So substitute the values. So substitute the formulas. That is 3.5 into JPS is pi d to the power of 4 by 32 divided by pi by 32 into d naught to the power of 4 minus di to the power of 4. So that means 3.5 into 32 gets cancels, pi gets cancels. That will be equal to 3.5 into d to the power of 4 divided by d naught to the power of 4 minus di to the power of 4. Now you substitute the values of d naught and di. So that is equal to 3.5 into 100 to the power of 4 divided by 200 to the power of 4 minus 173.2 to the power of 4. So on some further simplification, you will going to get on the left hand side, which is theta h by theta s, which will be equal to 0.5. So this is how you will be able to solve this particular problem. Thank you.